Welcome back, students. We're just going to pick up right where we left off. So, in science, we were talking about the weather, and so specifically like pressure and humidity. And so, I'm just going to review the CFA from uh, the 16th. Gosh, that was a while ago. But I'm going to go back through that a little bit, talk about why each answer is what, and then I'll kind of show you where you can locate the today's activity, the air masses and fronts nodes. So this is going to be our, I guess, post today. I'll put the video underneath it, of course, but I'm just going to start off with the review of the pressure and humidity CFA. Like I said, this grade wasn't going to count against you in Infinite Campus, but it is a good indication on what I think we need to cover again, or what if we can move on and stuff like that. So it informs me as a teacher on your learning. So to kind of go back through this and review a little bit, we have two boxes, and this question says the boxes below represent areas with with low pressure and high pressure. Would you expect the air or the wind to move right or left due to the difference in pressure? So the difference in pressure is what these two things are here. So on one side you have high pressure, on one side you have low pressure. So we have a difference in pressure between these two locations. And so we're trying to think, okay, what direction would the air move between these two? And the way that I like to think about this is with high pressure, it's kind of like if you have one of those, like a water bottle, and you like twist the bottom, you notice that the pressure on the inside of the bottle cap, or on the inside of the bottle, gets really hard, right? Like it's hard to squeeze that bottle because the air pressure is so high in there. And so if you spin the cap, or you try to like knock the cap off really quickly, it launches the cap away because all that trapped air on the inside is trying to push out of the bottle. And so once it has an area where it can go, it's going to go to the area of low pressure, which would be on the outside of the bottle. So there's a difference. On the inside of the bottle is much higher in pressure than the outside. And so the air is always trying to get from the high pressure area to the low pressure. And so with that in mind, the air, or the wind in this case, would move to the left. So this would be your answer here. For the second one, what kind of weather would you expect a low pressure area to have? So on one side we have stormy with high winds and precipitation. On the other one we have calm with clear skies and a light breeze. So in a low pressure area, and we'll talk on this a little bit today, but in a low pressure area, that air is actually moving away from the ground. It's being evaporated, and for the most part, it's being pulled up uh, through the atmosphere. And so, as it pulls up through the atmosphere, it's causing that air to condense, or excuse me, the water vapor in there to condense. And so, it's going to lead to a lot of precipitation, as well as some high winds, because it's a more volatile, or like a more disruptive pressure in the atmosphere. With a high pressure, the air is actually coming down towards the ground, and so you end up just getting clear skies and just a nice light breeze. But when the air is coming away, you have all the air on the ground basically funneling towards this one area and getting sucked up into the atmosphere. And so that's why we end up having a lot of precipitation as well as high winds. So stormy, it would be your answer for that one. And I kind of just did that. Uh, for number three, if an area has 100% relative humidity, which of the following types of weather would you expect? So, an earthquake, lightning and thunder, sunshine, precipitation, or wind. So, an earthquake is made by the earth, the tectonic plates that are moving. So, it's not that one. Lightning and thunder, while it usually comes with like a rainstorm, it is not because of the humidity that's in the air. It's from a different phenomena that we'll probably talk about a little bit later. Sunshine, that's the sun, so it's not that one either. And the wind, remember, humidity is how much of the water column has, or how much of the air mass has water in it. So, like, what percent of that uh, air air mass has water filled with it. And so if it was 100% filled with water, remember, we would call that air mass saturated, and so it would end up precipitating because that water would be forced, kind of like a sponge, it'd be forced out of that air mass, and it would have to go somewhere. So if it would start creating clouds first, and then once those clouds became heavy enough, or those water droplets in the clouds became heavy enough, then they would start being pulled down to the ground through gravity. So precipitation is your answer for the third one. And then lastly, dew is often seen on grass in the morning. Why is dew most common in the morning? So we have four answers that are possible. Air temperatures are warmer in the morning, which allows moisture in the air to condense onto the grass. Air temperatures are warmer in the morning, which allows moisture in the air to evaporate onto the grass. And then on the other side, we have air temperatures are cooler in the morning, which allows moisture in the air to condense onto the grass. And then the last one, air temperatures are cooler in the morning, which allows moisture in the air to evaporate onto the grass. So if our air temperatures were more warmer in the morning, which I don't know about you, but if I walk outside in the summer, usually it's a little bit colder in the morning. I have to put on like a little jacket, and then usually by the time that it's like 9 or 10 in the morning, then I can take that jacket off. But if I go out pretty early, it's not warmer than it is during the middle of the day. Um, and so the two answers that make sense to me in my mind are the air temperatures are cooler in the morning. So now I have to try to figure out, is it causing the moisture in the air to condense onto the grass, or is it causing the moisture in the air to evaporate onto the grass? And so if I think back to when we did the states of matter, if I remember correctly, the condensation is going from a liquid to a solid. So, or excuse me, a gas to a liquid. Sorry, gas to a liquid. So we have air moisture in the air, or like water moisture in the air that is condensing or turning into a liquid on the grass. And then on the other side, evaporation was going from a liquid to a gas. And so it doesn't make sense to me if we have cooler temperatures, but the air is evaporating onto the grass. Like it would be going from water in the air to a gas on the grass, which wouldn't make sense because that wouldn't give us dew in the end. So the answer that makes sense to me, oops, is this third one here. So air temperatures are cooler in the morning, which allows the air to condense onto the grass. So that would be your answer for the fourth one. So if you have any questions on these uh, questions or the CFA, I will be in the Google Meet all day today. So I'll be in third period, fourth period, fifth period, and seventh period. So hop in and ask me questions. Remember that this doesn't affect your grade, but it is a good indicator as to what, um, as a class, we know and what I might need to go back through or cover again. And so if you have questions or would like more clarification, let me know. But coming back to our Google Classroom for today. So we have our post here. There will be the video down here that you can watch, the one that I'm doing right now. But if you click on classwork, and it says this right here as well. So today's classwork, it's found under the weather topic in the classwork tab. So click on classwork, and it is not December 16th activities. It is actually, so this is what will show up at the front. Obviously, the semester one assessments. If you scroll down just a little bit, or on the left side, if you click on weather, it'll jump you right to it. And this is the most recent one that was posted. And we're doing the air masses and fronts notes. So when you click on them, it'll pull up something like this. And today, your activity is just to go through these notes. I would again recommend taking notes on these. You'll need to know about warm fronts, cold fronts, occluded fronts, and stationary fronts, and what happens when to the air masses, like what creates different fronts. Um, and this does a really good job of kind of explaining what is happening in each of those cases. So take notes on those. Remember that you can use all the notes that you take on the test probably later next week, maybe early the week after. But we're going to try to get it in, I think, before semester two ends, I believe, but don't quote me on that. So anyway, yep, this is your task for today. Again, if you have any questions or anything like that, I would be happy to assist and help you out. There are diagrams in a lot of these, so visuals can kind of help you piece together what's happening as well as the words. But yeah, I'll be in the Google Meet for third, fourth, fifth, and seventh period. So I hope you all have a wonderful Monday. Welcome back to school, and I will talk to you later.